Hello there, grade 7 students or Matayom 1. Welcome now to our second topic of this chapter 5. It's very important we understand this science. Now, chapter 5 about atoms, elements, and compounds. All right. So this is it now. Topic 5.2 elements. As I already said in the previous video, you can turn on your subtitle or translation in Thai, and I want you to watch this in Thai language. And also you can repeat this many times so you will be ready for your midterm test. All right. Okay. So here it is about elements. There are many different types of atoms with different numbers of protons, electrons, and neutrons. Yes? These different types of atoms are known as elements. Okay? And so elements are pure substances that cannot be broken down into other simpler substances by physical or chemical means. Now, the atoms of an element are similar. For example, the gold is made up of atoms only, and then the iron is made up of iron atoms only. Now, some elements have atoms of the same type combined to form molecules. For example, oxygen gas is made up of molecules, and its molecule of oxygen is made up two atoms of oxygen. So hydrogen gas is also made up of molecules, and each molecule of hydrogen is made up of two atoms of hydrogen. And so here, the most abundant elements in our earth is oxygen, which is 47%, followed by silicon, which is 28%, and then aluminum, which is 8%. All right. Now you can see other elements in here. All right. Like iron, calcium, and others. Now, so far, 118 elements are discovered. Most of them occur naturally. Some of them are made in the laboratory. Now, here are some examples of elements with their symbols. Okay? So we have hydrogen, which is H, oxygen, which is O, carbon, C, nitrogen, N, calcium, Ca, and sodium, which is Na or capital N, small letter A, magnesium, capital N, small letter G, aluminum or aluminium, big letter A and small letter L, boron, capital B, silicon, capital S, and small letter I or C. Here's the amazing facts. The most abundant element in our body is oxygen. It makes up about 65% of our mass. Carbon is the second most abundant element as it makes up about 18% of our mass. The third one is hydrogen, which makes up about 10% of our mass. Now, the symbol of each element has one or two letters. Okay? For symbols with two letters, the first letter is a capital letter, while the second letter is a small letter. All right? Now, different elements have different properties as shown in the table below. We have here hydrogen. The appearance is a gas. The melting point is minus 59 degrees centigrade. The boiling point is minus 53 degrees centigrade. Density is 0.000082. This is grams per cubic centimeter. All right. And the electrical conductivity, no. Heat conductivity, no. Now you can also see the oxygen. The appearance is gas. Melting point is minus 218 degrees centigrade. Boiling point is minus 183 degrees centigrade. Density is 0.0014 grams per cubic centimeter. And then you have the electrical conductivity, which is no heat conductivity. Nitrogen is also gas. It melts at minus 210 degrees Celsius. And it boils to minus 195 degrees Celsius. And the density is 0.0012 grams per cubic centimeter. And there is no electrical conductivity, no heat conductivity. Carbon is also, it's solid or black, and it melts at 3,550 degrees Celsius. But the boiling point is 3,825 degrees Celsius. The density is 2.26 grams per cubic centimeter. And then, yes, there is electrical conductivity and there is no heat conductivity. What about calcium? It's solid. It's a dull gray color. It melts at 842 degrees Celsius and it boils at 1,484 degrees Celsius. And the density is 1.55 grams per cubic centimeter. Yes, there is electrical conductivity, and yes, it is a heat conductor also. Now for sodium, it is solid, shiny color. It melts at 97.8 or 80 degrees Celsius, and it boils at 883 degrees Celsius. The density is 0.968. Yes, it is an electrical conductor, and it's also a heat conductor. Magnesium, it's solid. The color is silvery white, and it melts at 650 degrees Celsius, and the boiling point is 1,090. Density is 1.738 grams per cubic centimeter. And the it is electrical conductor, and it is also a heat conductor. Aluminum or aluminium in British English. All right, this is solid silvery white. It melts at 660.3 degrees Celsius and it boils at 2,519 degrees Celsius. The density is 2.7 grams per cubic centimeter. And it is an electrical conductor and also a heat conductor. Silicon, it's solid. It melts at 1,414 degrees Celsius. It boils at 3,265 degrees Celsius. It is dense as like 2.33 grams per cubic centimeter. And yeah, slightly it's an electrical conductor, and also it is a heat conductor. Mercury, it is liquid, silvery white in its color, and it melts at negative 38.89 degrees Celsius. It boils at 356.73 degrees Celsius. It's 13.53 dense grams per cubic centimeter, and it is an electrical conductor and a heat conductor. Now, what I want you to do is to understand more. Although each element has different properties, Some of them share similar properties. Scientists classified all the elements in a table called the periodic table. This enables us to study the elements in a more systematic way. We have seen here the table divides the elements into groups and periods. You see that the color here, this color like light sky blue, and we have the yellow color, and then we have the like pink color. All right, now I want you to understand that the color here, yellow, is the metal, and this pinkish is the semi-metal, and then the bluish is the non-metal. I want you to understand that each element here, like this example, the carbon, it has some elements inside, symbol of element, the carbon, and we have 6. It means it has 6 proton number, and we have the 12, the relative atomic mass. Okay, so each one of them has this proton number and relative atomic mass. All right, so there's a lot in here. It's too much for me to mention all of them in a video like this, but I just want you to understand, and you can download, you can also screenshot this one, and you can find it somewhere. There's a lot of copies of it on the internet. All right, but what I want you to do is the vertical columns of elements in the periodic table are known as groups. Okay, vertical columns are groups. I want you to understand that the horizontal columns are known as periods. So groups and periods. All right, and then there are 18 groups and 7 periods of elements in the periodic table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 7 periods. All right, 1, 2, 3, 4, 5, 6, 7. This is here. It's you know, extended down below. All right, that's interesting. This lanthanide series and this actinide series. Okay, well, there will be another topic for that, but for now, it's just to understand that elements can be classified into 3 main groups, namely metals, nonmetals, and metalloids. Okay, remember? And then elements to the left of the periodic table are metals, these ones, except hydrogen. Okay, and then elements to the right are non-metals. Okay, and then metalloids, separate them in the table. Okay, now let's understand. We can understand better if we work it. We don't have a workbook with you, and so skip this one. You don't need it. But I want you to understand more about metals. Okay, so most of the elements are metals. What are metals? So metals are solids at room temperature with high melting and boiling points, except mercury. All right, it's liquid, right? They are usually shiny. Look at that. They are good conductors of heat and electricity. We can pound them, pound, like you're going to pound like this, press, pound with a hammer or anything that looks like it. We can pound them into sheet as they are malleable, malleable, and pull them into wires like this one as they are ductile. They usually have a high density, very dense, high density, okay? That's why it's hard. And then we have here non-metals. What are non-metals? Okay? They can exist in the states of solids, liquids, and gases. They have low melting and boiling points. All right. Examples of nonmetals in gaseous state are hydrogen, helium, nitrogen, oxygen, and fluorine. Bromine or bromine is a nonmetallic in liquid state. Carbon, phosphorus, iodine, and sulfur are examples of nonmetals in solid state. They have dull surface, they're brittle, and non-ductile. Nonmetals do not conduct electricity and heat except carbon. Look at that. There's an exemption to the rule, right? So they usually have a low density. I wanted to see the sulfur. You see, it looks like cheese, right? Yeah, nice looking. Okay, so let's talk about metalloids. What are metalloids? Only a few elements is boron, silicon, germanium, arsenic, antimony, and tellurium are metalloids. These elements are unique as they have some metallic properties and some non-metallic properties. They seem to have the solid metallic appearance, but they are brittle, like this silicon on the right part. Unlike metals, they are neither malleable nor ductile. At room temperature, metalloids are poor conductors of electricity. All right. However, they become better conductors at high temperatures. Oh, that's why they can become conductor. It depends on the temperature. Okay. So here's the comparison of properties of metals, nonmetals, and metalloids. We have here the state at room temperature, like solid except mercury. And here for nonmetals, I mean metals are solid except mercury. We talked about that already. And the nonmetals are solid, liquid, or gas. The metalloids are solid. Okay. Now the appearance of metals is shiny, and nonmetals, they are dull, and metalloids, they are dull or shiny. What about their malleability and ductility? Okay, metals are malleable and ductile. Nonmetals are brittle and non-ductile. Metalloids are brittle and non-ductile. What about the melting and boiling points? As we know, metals, they melt and even boil at high, degree centigrade, except mercury. And nonmetals are low in boiling and melting, except carbon. The metalloids varies. It means they change. What about their conductivity? Well, metals are good heat and electrical conductors. And nonmetals, they're poor heat and electrical conductors. And metalloids, some conduct electricity and heat depending on the temperature, the one we talked about already. Okay, forget this workbook. What about radioactive elements? What are they? So radioactive elements are elements that break down, forming other elements. The nucleus of a radioactive element is unstable. The nucleus will break down naturally, randomly, and spontaneously without any outside force or stimulus. When this happens, the amount of the element reduces, forming new elements. So this picture is a hazard symbol for radioactive elements. Okay. Now, this decay process releases radiation which contains energy and some charged particles. These radioactive elements undergo radioactive decay over a period of time until they reach a stable state. The decay refers to the loss of energy. Okay? Look at the nucleus of this radioactive element. The decay event happens here with a charged particle and also the nucleus of new element. All right, so this is the decay of a radioactive element. Okay, now there are three types of radioactive radiations, namely alpha radiation, beta radiation, and gamma radiation. Now, what is alpha radiation? Now, it gives out the alpha particles that are positively charged. In an electric field, they are deflected toward the negative electrode. These particles are relatively heavy and slow. They have low penetrating power as they can be stopped by a piece of paper. All right, what about the beta? Beta, it should be beta radiation. Sorry for that. I'm not a native speaker of English. You just understand my English though. I want you to read here on screen so you can understand what I'm saying, just in case I miss some. So beta radiation gives out beta particles that are negatively charged. In an electric field, they are deflected toward the positive electrode. They are fast and light. These particles have the medium penetrating power, and they can be stopped by a sheet of aluminum or aluminium, right? What about the gamma radiation? Now, it is wave, not particles. In an electric field, this radiation is not deflected and travels in a straight line. Now, this radiation has high penetrating power as only a thick sheet of lead or concrete can reduce it significantly. All right? It's a lead or a lead. You better find a right pronunciation for that. Okay? Okay. Since this is a noun, it should be lead. So a thick sheet of lead. If it is a verb, it should be lead. All right. So it's lead. Now, you see here, this is paper and this aluminum, and we have this lead. All right. So the alpha radiation passes through paper, aluminum, and even, look at that, and only until paper, I should say. But beta radiation can even pass through paper to the aluminum. The gamma radiation is the one which is more penetrating because it passes here, paper, aluminum, and even this part, lead. So penetration capabilities of radioactive radiation. So be careful with this radiation, because in my previous topic, I think we talked about it, the gamma radiation is dangerous. It can cause cancer, all right? Okay, now, what about this plate? There's a positive plate and negative plate, all right? So you see the beta, the direction is like going up right there, and the gamma just straight, and the alpha goes down somewhere, okay, to the negative. So the beta tends to go to the positive plate, while the alpha tends to go to the negative plate. So the direction of radioactive radiation in an electric field. So again, gamma radiation, this one, always accompanies alpha and beta radiations. It accompanies, they go together. And right here, what are some effects of using metals? Okay, nonmetals and metalloids and radioactive elements. All right. We understand that as metals are strong, malleable, and ductile, and have a high boiling and melting points, we use metals a lot in our daily life. Can you remember them? Where do you find them? Well, you see them as like the metal in cars. Our vehicles and bridges are made from iron, as this material is strong and easy to press into desired shapes. Okay? Our wires here are made of copper, because copper can conduct electric efficiently. Copper wire. Tungsten is used in making the filaments in bulbs, as it does not melt at very high temperature. This area here. Tungsten filament, remember the filament? All right, in your bulb. Our pots, pans, and kettles are made from steel or aluminum, as they are good heat conductors, allowing the food to cook fast and water to boil fast. All right? Now, nonmetals are very useful too. We use nitrogen to make fertilizers, oxygen used for respiration and burning. Okay, when you go underwater, you need oxygen for breathing, and then argon and xenon are used in colorful glowing signboards. You go to Pattaya or somewhere around here during nighttime. Okay, iodine is used as antiseptic to clean wounds. All right, and helium is used in weather balloons. Liquid hydrogen is used as rocket fuels. Oh, okay. So metalloids are used a lot in chemical, electronic, and alloying industries. They are used to make semiconductors that can conduct electricity at certain conditions, enabling them to control the flow of electricity. Silicon is best known in making tiny electric circuits in computer chips. So your cell phones now are made up of electric circuits, from silicon. That's why in the USA there is such a Silicon Valley. Well, they have lots of silicons in producing these gadgets and the technology. Okay, so what about radioactive elements? They are used in many industries. They are used to detect leakage in pipes and thickness of metallic foils and paper, and as tracers in agriculture and medical industries. Radiations are used to treat cancer patients and to sterile surgical tools in hospitals. All right? They are used in radioactive dating, whereby the age of artifacts is determined, like how old is it? Is it like millions of years or just thousands of years? The radioactive elements are used in nuclear energy production. Okay? So whenever you see this sign, this is a radioactive element. Okay? So be careful. Although elements are very useful, the extracting processes and the extensive use of these elements have great effects on the environment. Okay? Like mining sites create land, water, and air pollution. Deserted mines create large areas of barren and lifeless land, and some waste materials from metal extraction are highly toxic to living things. The radiation emitted by the radioactive elements is very harmful to living things. The radiation can pass through our body and change our genetic makeup in our DNA. It can cause some of the things that we don't want, like this can cause mutation in our body, leading to higher cancer cases and child deformities. How dangerous. Besides that, plants and animals will be affected too. Reproduction of living things may be affected too. So, what can we do here? Nuclear energy production has its disadvantages. What are they? People working in these power stations are at risk of being exposed to radioactive radiations if the proper procedures are not followed. The byproducts and waste products are still highly radioactive. They must be stored or disposed properly. These power stations pose great risks when the safety procedures are not followed and when accidents happen. For instance, a nuclear plant in Chernobyl, Russia, leaked in 1986 that caused excessive amounts of radiation pollution in that region. Did you hear the story? You can Google that or find somewhere else. In 2011, a major earthquake caused a nuclear accident in Fukushima, Japan. It is believed many radioactive substances leaked into the atmosphere and the ocean. So we should use the elements safely, effectively, and economically. We should recycle the materials whenever we can. And for the dangerous radioactive elements, they must be stored in containers which are made of thick lead so that the radiation is contained. Let's watch this video about this periodic table. Maybe we don't need that one. I explained it already. So much for this video. It's a lot already. Let's move on to the next one. All right. No need. Okay. So no need for this workbook because you don't have it. Just go to the conclusion. Each element has their own particular properties. Some share some similar properties. Elements can be divided into three groups: metals, nonmetals, and metalloids. Remember? And metals have shiny surfaces, high density, and high boiling and melting points. They're ductile. They can be shaped into thin rods. Malleable, can be shaped into thin sheets, and good heat and electrical conductors. Nonmetals, on the other hand, have dull surfaces, low density, and low boiling and melting points. They're not ductile or malleable. They break easily and are poor heat and electrical conductors. Metalloids, some properties of metals and some properties of nonmetals. Radioactive elements are elements that are not stable. The nuclei break down easily to form new elements while releasing radiation. There are both advantages and disadvantages of using metallic, non-metallic, metalloid, and radioactive elements. We should concern the effects of their uses towards the living things, environment, and the economy and society. So I want you to answer here, page 110. Questions on Test Yourself 5.2. All right, and I'm gonna check it. Just bring your book to my table here on the third floor. See you later.